Centripetal acceleration. So the centripetal acceleration is the acceleration that a body feels towards the centre of a circle as it moves in a circle around that centre. The equation for centripetal acceleration is on the screen. A is a resultant acceleration. And if the resultant acceleration is always towards the centre of a circle, then the body will move in a circle, with the velocity constantly changing direction, but the speed remaining the same. V is the speed of the body, and r is the radius of the circular motion. There's another equation for centripetal acceleration for if we are given angular velocity instead of our tangential speed. The angular velocity was covered in the section F3, units of rotary motion. But this equation works just as well. So the question is, which equation should we use? And the answer is, it depends on what we're given. If we are given tangential speed, then we use the left-hand equation. If we are given angular velocity, sometimes called angular frequency, then we use the right-hand equation. And in both equations, r is the radius of the circular motion. Now the left-hand equation shows that a is inversely proportional to r, and this is true when the speed of a body is constant. However, if the angular velocity of a body is constant, then the centripetal acceleration is proportional to the radius of that circular motion. So here is our equation for centripetal force. And here it's very simple. It is centripetal acceleration, which is a resultant acceleration, multiplied by mass when the mass is constant to give us the resultant force, which is a centripetal force. Newton's second law is in this form when mass is constant. And at A level, all the cases you will have is where mass is constant. So here is another diagram showing circular motion where we have movement, circular movement of this red particle around the centre. The acceleration is always towards the centre, and the velocity vector is always tangential to the circle. So here's a question. Calculate the force on a 70 kilogram person in a funfair ride spinning horizontally, in the horizontal plane that means, at 10 meters per second with a radius of 10 meters. And the diagram's been started for us here, but we can add to it. Let's add to it our radius from the center to the person. And we know that our centripetal acceleration will be in the opposite direction, from the person to the center. That will be the resultant acceleration if the person is moving in a circle. And in this case, there's nowhere else the person can move. They are in a circle. Let us draw the forces in black ink. We have the weight of the body acting down, which would be mg. We also have the friction force from the wall acting on the person upwards. And that force, I'm going to label that S. That friction force upwards is going to be equal in magnitude to the weight if this person is neither accelerating downwards or upwards. In this case, they're not. They're travelling in a circle on this funfair ride. And so the resultant force is equal to the centripetal force, which happens to be this push force, I'll label it R, a reaction force, from the wall of this funfair ride acting in towards the centre. So that force is equal to mv squared divided by r. That is the resultant force, where that resultant force is that pushing force from the edge of the funfair ride acting towards the centre. Let's plug our numbers into this equation. Mass is 70 kilograms. The speed that we're travelling is 10 meters per second. That's squared. And the radius is 10. And you can see that must be 700 newtons of force, approximately equal to the person's weight, making the person feel very disorientated indeed.